youtube-hostboxcse. In the series of data warehousing and mining lectures, we have seen basically about cluster, what is meant by cluster, and then we have seen what is meant by cluster analysis, and after that we have seen the requirements for the cluster analysis, and then we have seen the variables, something like numerical variables, which is called as interval value variables, and binary variables, and ordinal variables, categorical variables, and all these things. And the next part is major clustering approaches. As I told you, there are many clustering approaches. This also we have completed partitioning algorithms, hierarchy algorithms, density based, grid based, and model based, out of which we have already discussed a partition algorithm. That is, it will divide the list of data objects into different set of clusters. Okay. And in the cluster partitioning methods, again there are 3 points, 3 ways of doing that. One is k-means, second one is k-medians, and third one is cluster large scale applications. That also we will try to see today. This k-means is already completed. Today we are going to see k-medians. Medoids. This k-means is already completed. Yeah, this is our k-Medoids method. In the k-means algorithm, that is sensitive to outliers. That means we cannot, for suppose, what is the concept behind k-means? If it will take the mean, and based upon that the clusters will be formed. For example, there are employees who are getting salary there are 5 employees who are getting the salary 10,000 to 20,000. All these people can keep under one cluster. For suppose there are only 2 clusters in our example, assume it, right? And there is one more cluster which contain the employee details whose salary is range between 30 to 50,000. Now, if a new employee is added to our organization and he is getting a salary something like 1 lakh. Now, to place this 1 lakh employee to any of this cluster, that will become a big problem, because we need to calculate the average, that is the mean. Based upon the mean, we can form a cluster. Now, if I take that 1 lakh employee, the remaining 10 people will get affected. Obviously, if we keep that into that, if we take the mean, that will become the huge set of values to be inserted into that, which is again not a feasible method. So, to solve that, we are going to other method, something called as a k-Medoids method. See, since an object with an extremely large value may be sustainably distort the distribution of the data, instead of taking the mean value of the object in a cluster as a reference point, we can pick actual objects to represent the clusters using one representative object per cluster. Correct. Only one representative object per cluster. The initial representative objects or seeds are chosen arbitrarily. The iterative process of replacing the representative objects by non-representative objects continues as long as the quality of the resulting cluster is improved. The quality is estimated using a cost function that measures the average dissimilarity between an object and the representative object of the cluster. The concept is very simple. For suppose there are 2 cluster requirements, we will select the objects, 2 objects. Okay. Based upon the 2 objects, whatever the near elements are there, for the first object will be placed into one cluster, and whatever the near elements we have for the second object will be placed into another cluster. After that, we will calculate the total cost function. Based upon the cost function, we will say that whether the clusters are correct or not, whether we can improve the clusters. In that way, we will be processing. Okay, the concept is very simple. See here, these are the list of objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 objects are there. Assume that this is x-axis and y-axis. All these are plotted on a graph. Okay. These are different points on the graph, right? Which will be noting the x-axis and the y-axis, right? Total 10 objects are there. The 10 objects. Yeah, just for our understanding, I wrote x1 to x10. Sorry, x10 are the objects, and x and y are their coordinate points, right? Now what we need to do is we need to select two random objectives because we require two clusters. If I require three clusters, we need to select three random objects, right? Two random objects. Yeah, I have to cluster 1 which consists of 3, 4. Cluster 1 3, 4 is the nothing but the object x2. Cluster 2 consists of 7, 4. 7, 4 is the object number x8. Alright, I have selected 2 points, 2 objects. See, all these x1 to x10, I used to call them objects or data sets or data items. In all this comes under the same picture, right? Don't get confusion in that. And first we need to select 2 random representative objects, and then cluster 1. If you see our example, what is our cluster 1 value here? Wait. Yeah, cluster 1 is 3, 4. Cluster 2 is 7, 4. Right, now coming to this cluster 1. Write all the objects except the clustered the points which you have selected for the cluster. That is x2 you have selected and x8 also you have selected. So remove that and write down remaining points. X value, x coordinate, y coordinate, and the cluster 1 value is 3, 4, which is common to all the objects. Next, you need to calculate the distance. For this we are going to use Manhattan distance formula, which is already discussed in the cluster, in the starting part of the cluster analysis. You can just refer that video also once. The formula is something like this: 2 minus 3 modulus plus 6 minus 4. It is minus 1. Since it is a mod, it will take as 1. 6 minus 4 will get to 1 plus 2. It is 3. The cost is 3. Okay, we are calculating in this way. We need to calculate the distance or cost for each and every element in the list, right? In the same way, 3, 8. 3 minus 3 it is 0. 8 minus 4 it is 4. 4 minus 3 it is 1. 7 minus 4 it is 3. If you add that, you will get 4 again. 6 minus 3 will get 3. 2 minus 3 will get 2. 3 plus 2, 5. In this way, we need to calculate all the distance. We are removing the cluster x2 and x sorry, not clusters. We are removing the data items x2 and x8 since they are already kept into the clusters. Okay. Now, if you understand, we are calculating the cost for the C1 cluster. C1 cluster is 3, 4. In the same way, we need to calculate the cost for C2 also. C2 cost function will be something like this, or it should be C2 7, 4, 7, 4, 7, 4. All the elements again need to calculate the cost. 2 minus 7 it is minus 5, since it is modulus it is 5, plus 6 minus 4 it is 2. 5 plus 2, 7. Like this we will be getting all the cost. Okay, if you understand. Based for the cluster 1 we have calculated the cost, and for the cluster 2 also we have calculated the cost. Now we have cluster 1 cost and cluster 2 cost. Now what we need to do is compare cost of C1 and cost of C2 for every I and select the minimum one. Now what we need to do is we need to compare these two elements. What is the minimum into 3 and 7? It is 3, right? Next it is 4, and here it is 4, and here it is 3, 1, 1, 1 and 2, right? We can form the clusters from above representations with the minimum cost plus the cluster value. What is the C1 cluster value? Already predefined value, that is 3, 4 will be there, and x1 which is minimum, that should be will come under cluster 1. x3 which is minimum compared to C2, that will come, and x4 which is minimum for the first cluster compared to second cluster. So this 3 plus the default value 3, 4 come into cluster 1. Next, cluster 2 default value is 7, 4, and next x5, comparing these two, what is the least one? 3, which is present in which cluster? C2 cluster. So 6 comma 2, 6 comma 4, 7 comma 3, 8 comma 5, like this way we can get the elements into cluster 2. Is that clear? This is not yet completed. We have few more things. After that we need to calculate the total cost. Total cost will be something like this. See here, 3 comma 4, 2 comma 6 plus 3 comma 4, 3 comma 8 plus 3 comma 4, 4 comma 7. Yeah, see here, cost of 3 comma 4 comma 2 comma 6, cost of 3 comma 4, 3 comma 8 plus cost of 3 comma 4, 4 comma 7, right? And again cost of, in the same way, the second cluster default value is 7 comma 4, 7 comma 4, 6 comma 2, cost of 7 comma 4, 6 comma 4, cost of 7 comma 4, 7 comma 3. Like this we need to calculate all the cost, and after adding all this we got the value something like 20. Is that clear? Is that clear? Now we need to check the clusters which have formed are correct, or can we enhance that. To do that, what we need to do is, now let us choose some other points as a Medoid instead of 7 comma 4. We can choose other point and we need to repeat the same procedure. Let us choose randomly 7 comma 3. Now Medoid set is 3 comma 4 and 7 comma 3. After selecting this, again we need to calculate the distance, again we need to calculate the cost, again we need to calculate the total cost. After calculating the total cost, if you get value less than 20, then we can set this as the new Medoid set and we can form the cluster. If you get value greater than 20, then we cannot set this as the new points. Right? I hope you can understand and you can practice with this new Medoid points. Thank you very much. And if you are missing the flow, you can refer the previous videos. In the previous videos, from that you will get the continuation part. Thank you.